Hello again, fourth grade. I'm back with our lesson 1 for our Into Math work. And I'm going to try to do pages 5 through 8. If it runs a little long, or I wanted to do 5 through 10, but it may run a little long, so I may stop at page 8 and go on to 9 and 10 on a separate video. I just don't want these videos to be super lengthy for you. All right, so we're going to talk about understanding place value relationships. And when you're done this, you should be able to do this I can statement. So I can use a place value chart to compare the values of different digits and justify the comparisons. So remember, I showed our place value chart in the last video with our ones, tens, hundreds, thousands, 10,000s, 100,000s, and millions. So we are going to be using this museum insect inventory to help us understand our place value relationships. So we can see in this chart that we have insects and numbers. So the number of beetles, 1,240. The number of wasps, 19,725. And the number of butterflies, 11,100. Spark your learning. Some museums keep collections of insect specimens as a historic record. Experts keep track of inventory, inspect specimen cases for damage, and check that labels are set correctly. How can you show the number of beetles in the museum insect inventory? So for this first problem, we want the number of beetles. So we know for the number of beetles, we need 1,240. And we want to show this using place value blocks. Now remember, in the last video, we talked about the different place values, and I brought with me this time some actual place value blocks. So here we notice this would represent our ones place. Here is a one that represents our tens place. This represents our hundreds place. And then we have these big cubes that represent our thousands place. So we can see with these place value blocks how we would represent it. So now, how would we draw this with our own pictures? So I know when I look at this number, in my ones place, this right here is my ones place. Do I have any ones? Nope, no ones. The digit 4 is in my tens place. So I have 40 tens. How am I going to represent that? Well, I'm going to need how many of those? Because this is my tens. I'm going to need 4 of them. So I would draw 4 of my long ones. These are called longs. Now I don't need to draw the little lines, but you can see here in this example there's a little lines. You could draw the little lines up to show that there's 10 there. You would just need to make sure there were always 10, but we can just draw it looking like that. Now in my hundreds place, I have a 2 that represents 200. Well, how am I going to show that? Well, I need how many of those? I need 2 of them. So I'm going to draw 2 squares. So these are what's called flats. So these are each worth 10. These are each worth 100. And then in my largest place value for this number is my thousands. And I have how many thousands? I just have 1. Now to draw a thousands, it looks like a cube, right? It's a 3-dimensional shape as opposed to the others being flat. So to draw a cube, there are 2 ways you could draw it. This is the way I have learned to draw them, but this does not mean you have to draw them that way. I start out with, it's supposed to be a square. It's a little more rectangular than square. And I do a line and an angle from the top right hand or top left hand corner, top right hand corner, align at an angle, and then I connect them. Then the bottom right hand corner, I do another line at an angle, and then I connect these two pieces. And that's my thousands. The other way you could do it is to draw and just put TH inside so you know that it's thousand. Same thing here, you could just do, these are your hundreds, and then you could do this, just a T for your tens. So these are the two different ways you could demonstrate your knowledge of 1,240. Okay, so those are a couple different ways that we could draw it using our place value blocks and the pictures that we could draw. So let's go to page 6. So now we're going to build some understanding. The museum has 11,100 butterfly specimens. Describe the relationship between the values of the digits in the thousands place and the hundreds place in 11,100. So in order to answer that, we're going to do these pieces that are going to help us answer this question. So the first thing we need to do is we need to represent and describe 10,000s, thousands, hundreds, tens, and ones. Well, we know that the little square, the small cube equals the ones place. And in our number, do we have any ones? No, we do not. We know the long piece is for the tens place. In our number, do we have any tens? No, we don't. 0 represents none. Now, we see our hundreds place. So, our hundreds place has the flat, right? So, we're going to draw one flat. Okay, and this is our hundreds. Then in our number, what about our thousands? How many of those do we have? We just have one. Oh, there's a little piece of eraser on it. So again, if you so choose, you can draw it by making it kind of 3D. So there's your thousands. Now, when I look at this number, I notice I have a digit in the 10,000s place. Now, I don't have anything here that represents 10,000s as far as having one model that's going to represent 10,000s. But I know when I have one of these, it equals 1. How many of these little pieces does one of these equal? 10, right? If I were to stack 10 little pieces, wouldn't that equal one of these? So I need 10 cubes to equal one long. How many longs do I need to equal 100? If I were to lay out 10 of these long pieces, I would have 100. So I need 10 longs, 10 tens to equal 100. I needed 10 ones to equal 110, 10 tens to equal 100. How many of these do you think I need to equal one of these? Well, if I look going up, right, I would need 1, 2, 3, 4, 5, 6, 7. Whoops, sorry, I counted wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. I need 10 hundreds to equal 1,000. So how many thousands do you think I need to equal 10,000? I hope you said 10. I hope you're noticing a pattern. Every time I go up a place value, I am multiplying by 10. I had my ones. 1 times 10 is 10. I've got my tens. 10 times 10 is 100. I have my 100s. 100 times 10 is 1,000. And if I had 10 of these stacked up on top of each other, which I apologize, I do not have 10 of them, but 10 of these stacked up on top of each other would equal 10,000. So how am I going to represent that in this picture? Well, what I could do is, remember the tens was this long piece, and I'm at 10,000. So my plan would be to do a really big long piece, and I need to separate it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to do the same thing that I do with my cube. I need to make it three-dimensional to show that I'm using cubes, right? To show that I'm using the 1,000 cube. And then it kind of makes it look three-dimensional. And this whole thing is worth 10,000. Sorry, that's supposed to be a comma. So to represent our 10,000s, we have one of them. Our thousands, we have one of them. And our hundreds, we have one of them. And we don't have any tens and we don't have any ones in our number. So why did we use each representation? Because we know that 10 of those equals one of those, 10 of these equals one of these, and 10 of our hundreds equals one of our thousands. And then 10 of our thousands would equal 10,000s. Okay? And we notice that the size, so we use each representation because it equals each model represents the price value and then we notice about the size of each representation, it is 10 times more than the previous place value. And then describe the relationship between the values of the digits in the thousands place and the hundreds place. Well, if I look at my thousands and my hundreds place, I know that if I go from 100 to 1,000, I'm going to get bigger by 10. So it is 10 times more. So now we're on to page 7. So I want to look at our connecting to vocabulary first before I jump into what we're going to be doing. So connect to vocabulary. The place value describes the value of a digit in a number. Then we talked about place value, right? We said here's our ones, here is our tens, here is our hundreds, here's our thousands, so on and so forth, right? Those are our place values, and I even had a chart right here, right? This shows all of our place values. And I want you to notice that this part from ones to hundreds, this is our ones period. What that means is this group of 3 all fall within the ones section. So we've got the ones place, the tens place, and the hundreds place. And then we would have a comma here. In this part, this is the thousands period. And we would have a comma after the 100,000. So we have thousands, 10,000s, 100,000s. And then if I had this place value chart going longer, this would be our millions period. And we would have millions, 10 millions, 100 millions. Notice in each group we have ones, then we have tens, hundreds. This would be the thousands, the 1,000s place. Look at 10,000s, tens, 100,000s, hundreds. Then we have millions. This is our 1 millions. And we would keep going. We would have 10 millions and 100 millions. So after your initial, like you've got your ones, your thousands, your millions, after that, then you add tens to your place value period, and then hundreds to the place value period. See, 10 thousands, 100 thousands. This would be 10 millions. And then we would have 100 millions, and so on and so forth. Okay? So I just wanted to share that with you before we jumped and dove right into this part. So number 2. As many as 136,080 insect fragments could be found in the foods you buy at the grocery store. This means you might be eating bugs. What is the value of each digit in the number 136,080? So we're going to use this to help us answer this question. The value of each digit depends on its place value position. A place value chart can help you understand the value of each digit in a number. So first we need to write the digits for 136,080 in the top row of the place value chart. So 136,080. So I'm always going to start in my ones place. I notice that in my ones place I have a 0. So I'm going to write a 0 in my ones. I have an 8 in my tens place. So I'm going to write an 8 in my tens place. That equals 80. I have a 0 in my hundreds place, so I have no hundreds. I have a 6 in my thousands place. Now notice, I know it says ones here, but this, remember on my other chart I showed you, this is our 1,000s place. So I have a 6. This is my 10,000s place. What digit do I have in my 10,000s place? I have a 3. And what digit do I have in my 100,000s place? I have a 1. And notice, I don't have any millions, but notice, I know this says ones, but this is not the ones like down here. This is our ones period. This is our thousands period. This is our millions period. So this is our 1,000s place. This is our 1 millions place. 10 millions place. 100 millions place. Okay? And I would actually have a comma here. So what is the place value position of the 6? So if we look at the 6, remember, it's not the ones place, it's the thousands place, the 1,000s place. And I'm just going to write thousands there. How can you find the value of the digit 1? Well, how do we find the value of the digit 1? We look at our place value chart and we see that a 1 is in the 100,000s place. So on the place value chart, the 1 is in the 100,000s place. Now we're going to fill out the rest of our place value chart. Write other ways to find the value of the digits in the place value chart. So if we notice, this is the part where we're going to use words to write our number, and this is where we're going to write the value of the number. So if I have 0 ones, I'm going to have a 0 in the ones place. I'm going to have 0 ones, and that is worth 0. The value of it is 0. If I have an 8 in the tens place, that equals 8 tens. And 8 tens is the same as 80. I have a 0 in my hundreds place, so I have 0 hundreds. And the value of 0 hundreds is 0. I have a 6 in my thousands place, so that means that I have 6 thousands. And the value of 6 thousands is 6,000. I have a 3 in the 10,000s place. So that means I have 3 10,000s. 3 10,000s is worth 30,000. And I have a 1 in the 100,000s place, which tells me I have 100,000. And this is how 100,000 looks. Notice 100 this comma you would say 1,000, and then the 0, so 100,000. So on our place value chart, every time you move up a place value, when you go from 1s to 10s, you're going up by 10. As you go from 10s to 100s, you are also multiplying by 10. You're going up one place value. As you go from hundreds to thousands, you're also multiplying by 10. As you go from thousands to 10,000s, you are multiplying by 10. From 10,000 to 100,000s, you are multiplying by 10. And so on and so forth. 100,000s to 1 millions, multiplying by 10. Millions to 10 millions, multiplying by 10. And 10 million to 100 millions, you are multiplying by 10. So the place value, the value of each place in the place value chart is multiplying by 10. So you're always going to be multiplying by 10 when you transition from one place value to the one that's right next to it. As you get bigger, you're getting bigger by 10, multiplying by 10. Alrighty, so we're going to step it out now for number 3. Yellow jacket wasps live in colonies that can contain up to 15,000 wasps, while bee colonies can have as many as 50,000 bees. How does the value of the digit 5 in 50,000 compare with the value of the digit 5 in 15,000? So to answer this question, we're going to have to answer A through D. All right, so the first thing we're going to do, it wants us to use a place value chart to help us compare. So first, for letter A, we need to show 15,000 in our place value chart. Well, if I look at the number 15,000, I know I have 0 ones, I have 0 tens, I have 0 hundreds, I have 5 thousands, and I have 1 10,000s. So the value of the digit 5 is 5,000. If I show 50,000 on this chart, this place value chart, I can put, I have 0 ones, 0 tens, 0 hundreds, 0 thousands, and I have 5 10,000s. So that means the value of the digit 5 in this number is 50,000. Which digit 5 has the greater value? Is it the 10,000 or the 1,000? Well, it would be the one that's in the 10,000s place. So the 50,000 has the greater value 5. So that tells me that the value of the digit 5 in 50,000 is 10 times the value of the digit 5 in 15,000. Remember, we went up in place value. We went from the 1,000s place up to the 10,000s place, which is by 10. Alrighty, so we're going to do the check for understanding. There are over 2,000 different species of jellyfish. The largest species have tentacles 200 feet long. How does the value of the digit 2 in 2,000 compare with the value of the digit 2 in 200? So if I have 200 compared to 2,000, I know that my digit 2 in 2,000 is bigger than 200. How much bigger is it? It's 10 times bigger. That is how it compares. It's 10 times larger because you're going from the hundreds place value to the thousands place value. Now we need to write the value of the underlying digit. So this number is 14,826. The 4 is in what place? If you're not sure, count it up. Your 6 is the tens, or the ones, I'm sorry. I apologize. I'm sorry, I was getting ahead of myself. The 2 is the tens. The 8 is the hundreds. The 4 is the thousands. So this equals 4,000. That's the value of the 4 in this number. What is the value of the 2 in this number? Well, 3 is in our ones, 1 is our tens, 9 is our hundreds, 5 is our thousands, 7 is our 10,000s, 2 is our 100,000s. So the value is 200,000. And write the value of this underlined digit. Well, we already figured we've got our ones, our tens, our thousands, or hundreds. Sorry. Ones, tens, hundreds, thousands, 10,000s. So our 7 is worth 70,000. All right, we are going to jump onto the on your own so we can just get this done. So number 5. In 2009, experts were called to a Baltimore wastewater treatment plant to remove orb weaving spider webbing. In the web samples that were removed, there were 31,194 spiders. Write the value of the digit 3 in 2 different ways. So we want the digit 3 in this number. What are 2 different ways we could write the value of it? Well, one way we could write it is, how much is that 3 worth? What is that value? Well, that value is in my 10,000s place. So I know that it is 30,000. Another way I could write it, well, I have 3 what? I have 3, which place value is it in? Is 30,000. 3, it would be here, right? So I have 3 10,000s. So another way I could write it is 3 10,000s. The praying mantis collection at a museum includes 13,000 specimens, while another museum has a collection of 300 specimens. How many times as great is the value of the digit 3 in 13,000 than the digit of the value 3 in 300? Well, let's look. We have 300 and we have 13,000. I have a 3 in 300 in the hundreds place. The 3 in 13,000 is in the thousands place. So if I go from the hundreds to the thousands place, I am going up by 10. So it is 10 times greater. Attention to precision. Write the number in the place value chart, then compare the chart to find the value of each digit. So we need to, just like we did back here, right? We're going to write this number in our place value chart. So we're going to write an 8 in our ones place, a 1 in our tens place, a 5 in our hundreds place, a 3 in our thousands place, and a 2 in our 10,000s place. So an 8 in the ones place is worth 8 ones. A 1 in the tens place is worth 1 tens. A 5 in the hundreds place is worth 5 hundreds. This one's already done for us. A 3 in the thousands place is worth 3 thousands. And a 2 in the 10,000s place is worth 2 10,000s. How much is 8 ones worth? It is worth 8. How much is 110 worth? 10. This one's done for us, but how much is 500s worth? 500. How much is 3,000s worth? 3,000. And how much is 2 10,000s worth? 20,000. this is. I'm just trying to get this closer for you guys. Sorry. There. All right, number 8. A beekeeper studies a colony of honeybees that has one queen bee, about 250 male drones, and about 37,250 female worker bees. Write the value of the digit 7 and 37,250 in 2 different ways. So just like we did up here, right? In 2 different ways, we want to write the value of the digit 7. So how much is that 7 worth in this number? Well, we know that it is worth 7,000. So that means there are 7 thousands. And our last page for today, or for this video, I should say. Number 9. One day, a cricket chirps 115,200 times. The next day, it chirps 11,020 times. How many times as great is the value of the digit 2 in 115,200 than the value of the digit 2 in 11,020? And how do you know? Well, if we have 11,020, we know the 2 is in the tens place. And if we have 115,200, we notice our 2 is in the hundreds place. How much bigger is the 2 in the hundreds place than the 2 in the tens place? It is 10 times greater. How do we know that? Because there's a 2 in the tens place, and there's a 2 in the hundreds place. And we know that the tens place, right? And then with the hundreds place, so we know the hundreds place is 10 times bigger than the tens place. All right, write the digit in its place value position. So let's look at this number. We have 5,619. I have 5 thousandths, 6 hundredths, 1 tenths, and 9 ones. Right? If I write that number based on the place value, that's where they would go. This number over here, I have 605,981. So I have 600 thousandths. I have no 10 thousandths. I have 5 thousandths, 9 hundredths, 8 tenths, and 1 one. And our last one. Attention to precision. Compare the values of the underlined digits, then complete the sentence. 26,451 and 2,385. The value of the digit 2 in 26,451 is 10 times the value of the digit 2 in 2,385, right? Because the 2 in the 10,000s place is 10 times more than the 2 in the thousands place. 3,000 and 30,000. The value of the digit 3 in 30,000, we're always going to start with the larger number, is 10 times the value of the digit 3 in 3,000. Because the 10,000s place is 10 times more than the 3 in the thousands place. And the I'm in a learning mindset, I'm going to have you, that's an independent activity that's kind of like you as a thinker. If you are feeling confident or not so confident, let me know so that way we can adjust how our our lesson is going. If you're feeling comfortable with just doing it like this, with me doing the videos and pushing them out to you and you following along, great. If you would rather maybe do a Google Meet to learn this, we can also do that as well. So just let me know how you're feeling. I would like you, after this lesson, you should have a black and white sheet of paper that is lesson 1 homework and spiral review. I would like you to complete that black and white sheet of paper and get it into school in some way, shape, or form. If you receive the breakfast and lunch meals, you can put it in an envelope with my name on it and give it to them, and they will make sure it gets to me at school. Or an adult at home could drop it off at school, but in some way, shape, or form, please get the homework piece to school to me, so that way I can check it over and see how you're doing. All right, and that is the end of the lesson for today, and we'll be doing lesson 2. We probably won't get to lesson 2 until next week, but we'll see how this week goes. I don't want to overwhelm you, and this is kind of this video was really long. The previous video was a little lengthy as well, and you have other items you need to do every day. So, but again, let me know how your comfort level with doing it this way, and also get that homework sheet, and the back side is the spiral learning sheet. Please get that black and white sheet done for lesson 1 and turn it into me at school. All right, enjoy the rest of your day, and I will see you soon. Goodbye.